Hi everyone, my name is Geena Tacconelli and my topic was firefighters. Just an overview of what I'm going to be talking about. I'm going to discuss the relevance of this topic, what is a firefighter, what is fire, the hypotheses, the methodology, the data collected, and the recommendations. The learning objectives for this presentation are to understand what a firefighter does, to understand what fire is, to understand trends in firefighter fatalities from 2004 to 2013, to understand methodology behind the statistical analysis, to understand dangers of being a firefighter, and to make recommendations for firefighters. So what is the relevance of this topic? Well, the topic of firefighter safety and fatality is very relevant today because the firefighting profession is the 13th most dangerous job in America. Firefighters have to respond to a fire every 20 seconds in America, and the firefighting profession is something that is very important to the safety and health of everyone in the world. Without firefighters, there would be no one to stop fire from spreading and many people would get hurt. So this report was needed to talk about fatalities among firefighters, those who are risking their lives to save ours. So what exactly is a firefighter? Well, they are workers that drive fire trucks to and from fires. They put out fires using high-powered hoses or other methods specific to each fire. They help victims trapped in burning buildings or in dangerous situations. They treat those who may have been injured during a fire. They provide public education about fires and fire safety. They respond to not only fire emergencies, but also other emergencies like car accidents. And firefighters work abnormal hours, not the typical 9 to 5 shift of a normal working American. They usually work for 24 hours straight and then have about 48 to 72 hours off. So what is fire? For firefighters to be able to effectively put out a fire, they have to really understand what a fire is and how it works. There are 3 components needed to start a fire: fuel, heat, and air. There needs to be something that will burn, a significant amount of heat, and the oxygen needed for oxidation. And oxidation is the chemical process of fire that makes it happen. It is when oxygen mixes with another substance. If oxidation happens quickly enough and the conditions are right, speed, heat, and light will be released. And this release causes temperatures to rise very high and smoke to be released along with other toxic waste, and therefore making a fire. To continue about fire, there are 4 phases. Ignition is when all 3 components needed for the fire are all mixed. The growth is when the fire really ignites and starts growing. Fully developed is when nearly all the fuel is on fire or is burned and the temperature reaches its maximum level. And decay is when the fire's entire source of fuel is about burned out. There are also different classes of fire. As you can see in this little picture, there's class A, B, C, D, and K. Class A fires start from combustible materials like wood, cloth, paper, or plastic, and they leave an ash. Class A fires can be put out by lowering the temperature with something like water. Class B fires are flammable and combustible liquids such as tar, oils, alcohol, and gas. Water may or may not be able to put this type of fire out. Foam may be needed in certain cases. Class C fires are fires from electrical equipment like wires and computers. Dry chemical agents or carbon dioxide are used to put out this type of fire. Class D fires are combustible metals like potassium, lithium, and titanium, and special powders and dry sand are needed to put out Class D fires. Class K fires are fires from oils and fats, and they should not be put out using water. So the hypotheses I had for this report will be given. So now knowing what firefighters have to do and how dangerous their job is when dealing with fire, an analysis of firefighter fatalities will be shown along with trends in fatalities. Firefighter fatalities were analyzed over the past 10 years from 2004 to 2013. And the null hypothesis is that the amount of firefighter fatalities and injuries has stayed at a fairly constant rate over the past 10 years. And the alternative hypothesis is that the amount of firefighter fatalities and injuries have increased or decreased significantly over the past 10 years. And we will see which hypothesis was correct later on. So the methodology I used to figure out which hypothesis was correct and determine the trends in firefighters, I will now talk about. The number of fatalities and injuries each year, 2004 to 2013, was looked at and analyzed. The mean, median, mode, and standard deviation of fatalities and injuries was calculated and analyzed to find averages in the data. 90th, 95th, and 99th percentile statistics were found to show what 90%, 95, or 99% of the data falls at or below, and were used as decision statistics. Upper and lower tolerance limits were calculated at 95% confidence, meaning that 95% of the intervals will contain the true mean value. Two-sided tolerance limits were calculated to show the range or interval. OSHA injury and illness rates were also calculated for injuries, more specifically the OSHA DRC rate and the OSHA incidence rate. And lastly, the least square method of forecasting was used to predict the number of fatalities and injuries from 2014 to 2016 using the data collected. So data was collected and analyzed by many different categories of firefighting. Total fatalities were analyzed, and fatalities were analyzed by gender, male versus female, by type of duty, emergency or non-emergency, by activity type, responding and returning from the incident, training, on duty, on-scene fire, on-scene non-fire, and after. It was also collected by cause, collapse, assault, stress and overexertion, caught and trapped, struck by, fall, vehicle collision, lost, out of air, disoriented, contact with exposure, and other. Also by nature of fatal injury, including heart attack, trauma, burns, heat exhaustion, asphyxiation, violence, drowning, crushed, electrocution, CVA, and other. And by coverage area, either urban or suburban, rural, and federal or state parks / wildland. Okay, I'm now going to go through some of the data I collected. I'm not going to go through every piece of data because that would go over the time limit, but I'm going to go through some main things like total fatalities in each category, the OSHA injury and illness rates, and forecasting. So this figure 1.2 shows fatal injuries for each year and fatalities by gender. So as you can see, there isn't much of a change in total fatalities other than a slight, and there are many more male fatalities than female fatalities. This figure 1.1 shows fatalities by type of duty, and it can be seen that there are more emergency fatalities than non-emergency, and non-emergency fatalities have slightly decreased over the past 10 years. Figure 2 shows firefighter fatalities by activity type. After analysis, on-scene fire is the only category that has a noticeable increase with 55 fatalities in 2013 versus 30 in 2004. All other categories have showed a slight decrease or stayed. Figure 3 shows firefighter fatalities by cause of fatal injury. As you can see, stress and overexertion is constantly the #1 cause. On the plus side, over the 10-year span, there has been a slight decrease overall. Figure 4 shows firefighter fatalities by nature of fatal injury. The number is high, as can be seen. Asphyxiation, trauma, being crushed, drowning, and electrocution have shown somewhat of a decrease, and burns and heat exhaustion have shown a slight increase. All other categories have stayed about the same. Figure 5 shows firefighter fatalities by coverage area. No significant increase or decrease has been made in any coverage area. Urban and suburban fires went down in the middle of the 10-year and then went up in 2013. Fatalities from fires in rural areas has been pretty steady the entire 10 years, as well as wildland fires. Figure 6 shows total firefighter injuries compared to the average of firefighter injuries. It can be seen from this graph that over the 10 years, injuries have slightly increased. Figure 6 shows that the most injuries occurred while firefighting and on fire grounds. Other on-duty injuries stayed about the same, while on-scene at non-fire calls fluctuated greatly. Training injuries decreased, and responding and returning injuries increased. Figure 6.3a shows the OSHA TRC rate. As this shows, the TRC rate has slightly increased over the past 10 years, as have the injuries. And figure 6.b shows the OSHA incidence rate. Like the TRC rate, it has slightly increased from 11.2 in 2004 to the last recorded in 2009 of 14.8. Now figure 8 shows the forecast for firefighter fatalities for the next 3 years. As you can see by the trend line, the firefighter fatalities is projected to decrease in the future. Figure 9 shows the forecast for firefighter injuries for the next 2 years, and the trend line that shows injuries the trend line showing injuries shows a slight increase over the next few years. But then again, these projections are not always 100% accurate. So, firefighters are at high risk for many diseases due to their interaction with fire, smoke, toxic substances, and injured individuals. As you can see, I just showed how many firefighters got fatally injured and regularly injured. So, they're at high risk for heart disease is a very high risk for firefighters because being that heart attacks are the cause of 45% of work-related deaths for firefighters. And while fighting a fire, the risk is very high due to heavy work near hot fires, exposures to carbon monoxide, and the stress the job causes. High levels of stress make the heart want more oxygen. And if a firefighter is breathing in carbon monoxide, a heart attack can be the result. For cancer, it is a common health risk for firefighters because with this occupation, firefighters come into contact with a lot of cancer-causing materials burning in a fire. This puts them at a heightened risk for colon, brain, bladder, and kidney cancer. For chronic respiratory disease, this affects firefighters more commonly because of how many burning chemicals they breathe in, which could cause permanent lung damage. Hepatitis B and C are risks for firefighters because firefighters are typically the first workers to arrive on the scene of an accident, which exposes them to a lot of blood, which could be contaminated. And as you can see from the slide, stress is a #1 killer or a harm to firefighters because the job itself can be very stressful because people are relying on firefighters to save their lives. Additionally, when they're under stress, people tend to smoke more, which is a risk in and of itself. So there are many things firefighters can do to protect themselves and stay safe while doing their very dangerous job. But here are a few things I recommend firefighters do to reduce the amount of injuries and fatalities. First, they should have a knowledge of the hazards they are dealing with. They need to be aware of what could happen so they're ready for the worst thing to happen and they know how to react. They need to always wear personal protective equipment to save themselves, things like self-contained breathing apparatus. They need to make use of the safety tips they learned and relay them to everyday citizens. Additionally, they need to pay close attention during training so they know exactly what to do and when to do it. And they need to make use of the new technology that's being developed for them. For example, technology like Glanzer, phaser, and whisper systems. And these are systems that help locate firefighters that may be lost in a burning building or in a burning wildfire, and it sends the firefighters' vital signs to the commanders at the base. And that's all I have. Thank you for listening. And my references are attached in the Word document. Thank you.